Welcome to the channel of Engineering Chemistry Lab videos. Today's experiment is determination of COD in wastewater sample. So the aim of the experiment is to determine the COD is chemical oxygen demand in a given wastewater sample. So COD basically it is defined as the expansion of COD is chemical oxygen demand. It is a chemical oxygen demand. So COD is the amount of oxygen. It is the amount of oxygen required for complete chemical oxidation of inorganic salts, inorganic compounds and organic compounds. The inorganic compounds such as ammonia and nitrites using a strong oxidizing agent such as K2Cr2O7 in an acidic medium using sulfuric acid. So the definition of COD is to determine the amount of oxygen required for complete oxidation of organic as well as inorganic compounds, some inorganic compounds present in a water sample by using strong oxidizing agent in an acidic medium. So chemical oxygen demand is a measure of capacity of water to consume oxygen during the decomposition of organic matter. So it is basically the decomposition of organic compounds present in a water sample using strong oxidizing agent in presence of acid medium. All organic matter will be decomposed to carbon dioxide and water. So this is a typical general reaction where the K2Cr2O7 is a strong oxidizing agent. It donates single oxygen. Nascent oxygen is provided here to the organic compounds. So we are measuring, as per the definition, we are measuring the amount of oxygen required for complete oxidation of organic compounds. It means that we need to measure the amount of K2Cr2O7 that is actually reacted with organic compounds. Okay. So COD is a measurement of, it is commonly made on natural waters, contaminated water such as domestic water, sewage water or industrial wastewater. So generally the COD, in the estimation of COD, we use the strong oxidizing agent such as K2Cr2O7 in presence of sulfuric acid as an acidic medium. COD is commonly expressed in terms of milligrams of oxygen per liter, mg, milligrams of oxygen per liter, mg of oxygen per liter. Let us see the experimental demonstration first. Okay, before that, the measurement of COD has two titrations in it. One is the blank titration. Another one is back titration and the blank titration. You can see in back titration, 25 cm3 of wastewater sample is pipetted into conical flask. Again 25 cm3 of K2Cr2O7 is pipetted out into conical flask. Add 20 cm3 of dilute sulfuric acid to maintain acidic medium which contains silver sulfate in it. Boil about 30 minutes, cool the solution, then add ferrous indicator and titrate it against standard FAS solution taken in a burette till the color changes from bluish green to reddish brown. So this is the end point. If you compare the back titration and blank titration, here the sample is missing, right? We are not added sample. 25 cm cube of sample is not taken here. This is a blank. Without adding the titration, without adding the sample, we carry out the titration. The reason behind this is here, as I said earlier slide, organic compounds is oxidized using K2Cr2O7 in presence of acid medium to form carbon dioxide and water. Our idea is to know the amount of oxygen that has been consumed, which is given by the oxygen is provided by K2Cr2O7, and this oxygen is utilized by the organic matter. Okay. The reason that we are boiling the solution is it contains a long chain organic compounds. In order to break that compounds, we need to boil the solution. Okay. Hence, heating is required here. So here the idea is to measure the amount of K2Cr2O7 reacted. So in this experiment we are added A, let us call A is total K2Cr2O7 added, that is 25 cm cube. Out of A, B has been consumed, that is reacted with organic compounds. This is B. We need to find out B, but B cannot be seen. Okay, hence what we will do is we can calculate total K2Cr2O7 by carrying out blank titration. Can see here in blank titration we have not added water, but we can calculate total K2Cr2O7 added from blank titration. Okay, now the remaining K2Cr2O7 here, remaining K2Cr2O7 after oxidation is called as C. Let us call C as remaining K2Cr2O7. Remaining K2Cr2O7. So remaining K2Cr2O7 can be calculated by using back titration. Okay, so remaining total minus remaining, that gives reacted K2Cr2O7. This is the idea. So this is a reaction involved. Organic compound on addition of K2Cr2O7 which donates nascent oxygen in presence of sulfuric acid to form carbon dioxide and water. So this remaining K2Cr2O7 C can be measured by measuring blank minus back titration reacted. Okay, B minus A gives C. Let us see the experimental demonstration. As usual, we need burette, standard flask, conical flask, funnel, measuring jar, pipette. We need a hot plate to boil the solution. We need H2SO4, water sample, standard K2Cr2O7 ferrion indicator. Transfer part A includes the preparation of standard FAS solution. FAS is transferred into, known weight of FAS is transferred into the standard flask. Add sulfuric acid to dissolve the ferrous ammonium sulfate. The reason is it forms hydrolysis if you add directly water. In order to avoid hydrolysis of FeS to FeOH twice, we add initially the sulfuric acid, dilute sulfuric acid, then we add water to dissolve the solution. Transfer water. Make sure all the salts in funnel as well as in the neck of a standard flask has been transferred to the bottom. Mix the solution well until it dissolves. Once it is dissolved, add water up to the neck, remaining water, distilled water, to be added from the burette dropwise. Once it is done, invert the flask, mix the solution well for uniform concentration. Now you can calculate the normality of given FeS using the formula. Now rinse the burette with FeS solution. Fill the burette with FeS. Make sure the tip is also filled. Before titrating, note down the initial reading. Now, pipette out 25 cm cube of water sample into conical flask. We are carrying a back titration. Anyways, blank titration value will be given to you. Again, pipette out 25 cm cube of K2Cr2O7. Here, the K2Cr2O7 need to be pipetted out using different pipette. By back titration, we are going to calculate the remaining K2Cr2O7. Add sulfuric acid to maintain acidic medium. Now boil the solution by adding boiling chips to ensure the complete oxidation of organic matter present in a wastewater. Once the solution is boiled, cool the solution . Cool the solution. After cooling, add 2 to 3 drops of ferrous indicator. Please note, dear students, in this experiment, we may not heat the solution because we are not using a strong waste matter. Okay, hence, but in general, you need to heat or boil the solution before titrating. Add ferrous indicator. Now titrate the solution against standard FeS prepared in a burette till the color changes from bluish green to reddish brown. Should be very careful. Keep on adding dropwise. In between, mix the solution well. Can see here at the center of the solution there is a slight transformation of the color, reddish brown color. Now you should be more careful. Keep on adding dropwise. You can see there is a slight transformation over there. Now be careful, add dropwise, mix the solution well simultaneously. Mix the solution well, then again add 2 to 3 drops. Now you got your exact end point. So this is about the back titration. Note down the final burette reading. Now, blank titration is not done by your side. The blank titration values will be given to you, and the blank titration is titrated without adding the water sample. You need to pipette out 25 cm cube of K2Cr2O7 solution, followed by H2SO4, 2 to 3 drops of indicator is added, add ferrium, titrate it till it becomes bluish green to reddish brown. So this gives blank titration. So blank titration is measured to calculate the total amount of K2Cr2O7 or total amount of oxygen, out of which the back titration is measured to measure the actual K2Cr2O7 reacted. This is a particular reaction which I have already explained you. So this gives the amount of K2Cr2O7 consumed by FES, remaining FES here total FES, K2Cr2O7 here. So this is a burette tableau column. If the initial reading is 0, note down the final value. Suppose if it is 10, it will be 10. Now for second titration, before titrating you need to note down the initial reading. All 3 trials are compulsory and blank titration will be given to you. So blank minus back titration gives volume of K2Cr2O7 actually required for oxidation. Now let us move on to the calculation part. Similarly, here also you have 2 parts. Part A is meant for the standard solution of FES. Weighing bottle plus FES, that gives W1. Empty weighing bottle after transferring the FES into the standard flask, whatever the weight, W1 minus W2 is W. Find out the normality of FES, weight of FES into 10 by equivalent weight of FES, which is 392. Weight of FES transferred, W into 10 by 392. 10 is, we are reducing it for 100 ml. We are using standard flask containing 100 ml. So this is a calculation part. So back titer value B minus blank titer value given, that gives V, volume of K2Cr2O7 actually required for oxidation of organic matter, and 1000 cm cube of 1 normal FAS is equal to 8 gram of oxygen, right? You are donating nascent oxygen here. V cm cube of Z molar, Z normal, which is calculated earlier. V is this volume, V into Z by Z into 8, 8 is 8 gram of oxygen by 1000. That gives A gram of oxygen. 25 cm cube of wastewater sample required A gram of oxygen. So then 1000 into A by 25, 1000 into A by 25, that gives D. Now D into 1000, that gives mg of milligrams of oxygen per liter. That gives the COD. COD is D into 1000. This is your result.